Okay, today we're looking at a video on how to adjust window settings and zoom functions, specifically the zoom in, zoom out, zoom standard, zoom quadrant 1, and window settings. These are essential skills to be able to master graphing, as we can be looking at graphs in a variety of forms. To examine these today, we're going to look specifically at an example from Algebra 1 textbook, Unit 3, Section 3, Example 5. The example reads, the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight, where f of x is the number of miles a helicopter is from its destination. Which flight takes less time? Explain. Well, first we're going to start by looking at a picture of the graph. So this was in our textbook. We see here's our first flight. We can see this graph is focused in the first quadrant, which will be helpful for us later when we're graphing on our calculator. And we can see what's going on with it. It looks like the flight lands after 3 hours, all things that you've probably examined already. However, we do want to graph the second function, 350 minus 125x. So we're going to get started by going to our home screen. And as we've seen before, I can either do a new document with a graph, or I can go down and use my graphing shortcut, which I'm going to go ahead and do here. It immediately pops up a graph, and again, my function I'm doing is 350 minus 125x. 350 minus 125x. I hit enter, and I see what appears to be a vertical line. The issue here is that our window is very much off. So if you ever see like a vertical line or horizontal line, or just don't see your graph at all, you need to stop and consider what's going on there and whether or not something should be changing. In this case, as I look at my graph, I see it goes from -10 to +10. Now, x was the number of hours. Negative hours in this scenario have no relevance, no significance, they don't mean anything. The y value only goes up to 6.67, it goes to -6.67. We know the y value was miles. Negative miles, again, have no meaning, and it only takes us up to 6.67 miles, whereas I know from looking at my previous problem that their distance in miles went in the hundreds. So, returning to my graph, this is clearly just very inaccurate. So I'm going to start by using my window settings, which are under Menu, Window, to make some changes. You can see a bunch of them are in here. First one, most commonly used, zoom in and zoom out. Zoom in this problem, what it does, you click zoom in, it brings up a little magnifying glass that you can move around using your cursor, your center pad here. We'll move the magnifying glass around, and that tells you the center where it's zooming in on. In this problem, for example, there I've zoomed in, but still got a vertical line, and as we were thinking about before, with our problem going up to hundreds of miles, making my graph smaller probably is not the right way to go. So to get out of the zoom in option, I'm going to hit the escape button, and I'm going to try another option. Under Windows Zoom, I've got zoom out. I click zoom out, it gives me another magnifying glass. So I said, okay, great, I know I want to go in the hundreds. I'm going to zoom out a few times, and I can click enter a couple times, and it will zoom me out. But it's not doing a very effective job. You notice it's zooming out equally negatives and positives. And we said before, negative miles and negative time are just not helpful in this specific problem. So the zoom out can be helpful, but in this problem, not the most effective. Other options I have here are zoom standard. Zoom standard returns me to my normal -10 window. So with zoom standard, brings me back to the beginning. Zoom standard is very helpful for when you get yourself into a mess, like I kind of did before by zooming out. It didn't give me a better picture of my graph. All it did was make my graph more vertical. So back to the beginning, back to my starting point, zoom standard is really helpful. The last zoom option we're going to look at today is zoom quadrant 1. Zoom quadrant 1 I really like because it gives us a zoom just on the first quadrant. And in real life application problems, which are often ones we have to change the window on, we really are usually looking at the first quadrant. We're looking at time or volume or just different situations where we're not thinking about the negative values of that, where they're just not relevant. So I use zoom quadrant 1. That is nice. It did give me the positives. Notice it keeps a little bit of the negative side just to give me perspective where the axes are. But again, I'm left with a vertical line. So in that case, since none of these zoom options are helpful, I'm going to resort to the more complex one, which is window settings. Window settings is actually the most accurate, the most effective way to change my window. But it can be more complicated because I've got to specifically choose values. I don't just get to zoom in and out. So the window settings box, let's examine this. It has 6 different settings I can choose. X-min, X-max, X-scale, Y-min, Y-max, Y-scale. The X-min is the smallest X value. The X-max is the largest, so minimum for smallest, maximum for largest. So we're going to think, okay, what's the smallest X value in this situation? Well, I'm talking about a helicopter, and X is time. What's the smallest amount of time? 0. I'm not going to be having negative time. X max is the largest amount of time. Well, to think of what's practical here, it's got 20. And as if I look at the other graph, that can be helpful. My time is in hours. 20 hours might be a little much. This other one had 6. Well, I'll probably just use 6 as well. 6 seems like a very good number to use, comparing it with the other graph. X scale tells me how much I want my X value increasing by. How often do I have dashes on my line? And so in this case, I could do auto, and I think I'm going to just choose the value of 1. So I'm going up 1, 2, 3, 4, 5, 6 is my scale. Y-min's smallest Y value. Again, thinking about my problem, you've got to really think about, okay, in this situation, what is Y and what is the smallest Y? Well, in this situation, the Y is miles. Smallest miles, 0. I don't have negative miles. My helicopter is not crash landing and going underground. It is just going to land on the smooth surface. So 0 really would be my Y-min. My Y-max, definitely not 13. Again, referring to my other graph to help me think of, okay, what's practical. Looks like we're in the hundreds. Now, my distance might be more, it might be less than this helicopter. So I'm going to go a little bit more generous and maybe hit 400 for my distance. So my Y-max here, I'm going to go with 400. Y scale, how much do I want my Y going up by? Do I want it going up by 10, 20, 30, 40, 50? Do I want it going up by 1? 1 would probably be a little small. 1, 2, 3, 4, 5, 6, all the way up to 400, a little much. So more practical, maybe 50, maybe 100. I think I'll go with 50 for this problem. Great thing about window settings, you can do trial and error, try numbers out, see what happens. So changing my window, let's see what happened here. And there's a much more effective graph. I see a nice diagonal line, and I can compare it to the one in the word problem. Both diagonal lines and much better than a vertical line. Now that I've got an accurate window, I can move on and consider my table of values. Because the question in my problem, going back to the question, says which flight takes less time? So if I look at the one in the textbook, the graph here, this flight takes 3 hours. I can see it has landed, it's at height 0 at 3 hours, and so that's the length of time for that one. If I look at my new graph, I want to know, okay, how much time does this take? Remember, I set the scale at 1, so that tells me this should be a 2, this should be a 3, this should be a 4. It looks like it takes less than 3 hours, between 2 and 3. So it looks like this is less time. But to confirm, I'm going to go ahead and use my table of values. I like to use the Control-T shortcut and look at my table of values that way. Notice it brings it into the window. As I look at my table of values here, I say, okay, well, when X is 2, so when at 2 hours, the helicopter is 100 miles. At 3 hours, it's at negative 25 miles, which again has no relevance in this problem. We are not going underground. So that means it has landed and it has already been landed. So it hit 0 somewhere between 100 and negative 25. That confirms for me that this flight took less than 3 hours. So to answer my problem, which flight takes less time? The second flight would take less time. And we know from the graph that it landed before 3 hours.